All right, so this is not one of my favorite subjects that we talk about in here, but it's still an important topic, and so we're going to talk about it. But I don't love it because we're talking about the ideas of risk and life expectancy. So when we talk about this, we're going to talk about vital statistics. Vital statistics is the data that concerns births and deaths of citizens and are very important to understanding risk-benefit trade-offs. So, for example, insurance companies use vital statistics to assess risks and set rates. Health professionals study the vital statistics to assess medical progress and decide whether research resources should be concentrated. And then demographers, I'm not sure which way you'd say it, use birth and death rates to predict future population trends. So here's one about like the cause and the number of deaths: heart disease, cancer, chronic respiratory disease, accident, stroke, Alzheimer's, diabetes, pneumonia or influenza, kidney disease, suicide. So that's going to be, this table is showing the leading causes of death in the United States. Life expectancy is the number of additional years a person of a given age can expect to live on average. Oh, looks like we have a little bit left over from somewhere that shouldn't be there. That part doesn't matter. I'll have to change that before I put it up in D2L for you. All right, the chances of someone dying in a car crash is about, this example one, about 12.9 out of 100,000, which approximates to be about 1 out of 8,000. So what's the chance that you will die or not die in a car crash? All right. So this is 6.4, example 1. And we're looking at the probability of not dying in a car crash, right? So not dying. And that's the chance or the probability. It's the same kind of thing that's happening. So not dying in a car crash. Well, the total chances is still going to be 1 minus, we were given, it was 12.9 out of 100,000. I kind of reduced that down to an easier fraction. So 1 out of 8,000. Well, just like we did before, we're going to take that 1 and get it a common denominator of 8,000 out of 8,000, minus 1 out of 8,000. And so that will get us 7,999 out of 8,000. That would be our answer. So this should be a subtraction symbol. It looks, I got my equal sign going too early. All right, so get your common denominator and then subtract it out. So 8,000 minus 1 is 7,999 over a total of 8,000. All right, example 2. The figure shows the number of automobile fatalities and the total number of vehicle miles driven among all Americans for each year over a period of more than 4 decades. In terms of death rate per vehicle mile driven, how has the risk of driving changed? All right, so I have a bigger graph so we can see it a little bit easier. So if we look at this, we can see clearly that the risk has, the bars are representing the number of deaths. The line represents the vehicle's miles driven over the time. So not a lot of vehicles were driven back in 1970 compared to 2015. We had about 20,000 deaths, or the number of vehicles would have been, it's around like 20,000 versus up here. Well, this is per vehicle mile driven. How has the risk changed? So it didn't really give us like a total. So the vehicle miles these are the vehicle miles in trillions, so that's a lot of miles. This is the number of deaths, and then this is the year. So this one's weird because it has 3 sides on the graph. But we can see the miles driven go up, right? The typical miles that were being driven are going up, and but the number of death rates went down. So let's talk about that a little bit. And why? As you know, how has that risk of driving changed? First of all, there's the type of vehicles driven. They have more crunch zones. They were built before, like completely out of metal. They didn't have any plastic parts. So there weren't any crumple zones or crunch zones. It was impact. Some of the other things that have happened are seatbelts. You know, growing up in the 70s, we didn't wear seatbelts. That was not a thing that we did. We rode wherever in the car. I think the cars had seatbelts. We just didn't wear them. It wasn't a law back then. I remember when it became a law. And so, so safety features such as that, the shoulder belts, the seat belt part on the lap, and they only had seat belts. They didn't have shoulder belts. So then the shoulder belts were added, and also airbags came along. So the airbags help protect. And they've just built the cars more durable. So even though you're driving more miles, the death rate is going down because of the safety issues. Okay, so let me clarify that a little bit in some words. It's sometimes hard to have these discussions sitting all by yourself. There's nobody in the room to bounce off ideas. So the risk has gone down. And it's most likely due to better design and safety features. So seat belts, lap belts, and they had most of them I think had seat belts, but they did not, or not lap belts, sorry. Shoulder belts. They had the shoulder part that straps over. And also they had airbags have come along. So all of those things have made things a little bit, made it better. All right, our next example is, doesn't make sense. So your life expectancy is the major factor in determining how long you live. Does that make sense, that your life expectancy is the only thing that determines how long you live? Well, that doesn't make sense to me. It doesn't make sense to me at all. So the life expectancy is just a, hey, we expect you to live this long, right? But that doesn't determine how long you're actually going to live. So does not make sense. So it does not make sense, and it's life expectancy, that's an average. And the average is based on current medicine and public health statistics. But your lifespan is going to depend on many other factors. It's going to depend on what kind of genes you have, you know, as far as what kind of diseases run in your family. I have a friend, and everybody in her family gets some kind of cancer. It depends on what kind of cancer you get. Or you might have genes where there is no cancer popping up in your family. Whether or not you have heart disease, whether or not you're a smoker or a non-smoker. We've talked about that in previous lessons. There's lots of things that go into this. Also, there are things that happen that have nothing to do with what you have going on. Maybe you're involved in a really bad accident or something. So there are a lot of factors that can go into this. So Just because your life expectancy is this does not mean that's what's going to happen. So, it does not make sense. All right. Make sure you're doing your homework, and I'll see you at the next video.